Yes, okay. So yesterday, in yesterday's lecture, we have gone through the design of a knuckle joint, right? So design of a knuckle joint. So just only we will revise the things yesterday's, how it is going to fail, okay? Just only we will, once again, I will play that video. Just it will take only hardly 5 minutes, and then directly we will go for the procedure and one problem based on it. Okay, so knuckle joint, here it just will revise the things only. Okay, that rod A, rod B, that those axes are coinciding or intersecting where it is used. Just we will go through this only 5 minutes animation. And then this is under tensile force application, and which is having limited angular movement as well. So that knuckle joint is used in such applications. Here is the assembly, that fork is with double eye, single eye, and pin. These three are the most important part. Here is the cross-sectional view. Then when it is of tight fit, then double shear case. When it is of loose fit, then bending will take place in that particular pin. Okay, here it is of double shear case, then it is of a bending case. Okay, that when fork is under tensile failure and shear failure, then it is going to fail like this. So single eye, again tensile failure, shear failure, how it is going to take place likewise. Here is the cross-sectional view and all the notations. Okay, the tensile failure of a rod, how it is going to fail like this. Okay, so here is the formula to find out the diameter of a rod. Okay, and in empirical relation we can find out the enlarged diameter. Then shear failure of a pin. So P load upon area, that is P upon pi by 4 d square. It is of double shear case, that's why it is of 2 times. Okay, so all these formulas are important while solving the problem which are based on a knuckle joint. Yes, here is then crushing failure of a pin in an eye, that projected area. Yes, likewise, that A into D. So it is of 2 times. Then bending failure of a pin, the formula for same, the bending moment into y divided by moment of inertia, and here is the final formula to find out bending stress in that particular pin. So this is about bending failure of a pin. Then next is the tensile failure of a single eye. Then how it is going to fail, just see the animation. Likewise, then formula B into D0 minus D. Okay, you can find out the tensile stress. Then shear failure of a eye, which is of a double shear case. Then it will fail like this. Then you can put the formula in shear stress. Here is the shear failure of a fork or double eye. Then here is the formula. Thank you. So this is about the video or the how the formula comes. Okay. So this video will be very beneficial to you. Means that how formula will come that you can cross check over here. Now the next is the design procedure for the knuckle joint. Now design procedure means whatever we have seen the same as it is. Okay. So just you can note down as well. Okay, one by one. So the first is a calculate the diameter of each rod, right? So because that single eye and four they are having rod, okay, which is having same diameter. Okay, so first we need to calculate the diameter of each rod. How will you calculate? So the formula is capital D is equal to square root of 4p divided by pi into sigma t. Okay. So they will provide you the p value, that is tensile force value, and tensile stress value. You can find out the diameter of that rod. Okay, so you just note down in your notebook the formulas, the design procedure, because this design procedure is the most important. Okay, and already in video we have seen how that formula comes. Okay, so first we need to calculate the diameter of the each rod, that is capital D, by using this formula. Just note down the formulas. Now the second, calculate the enlarged diameter of each rod by empirical relationship. Now there is an empirical relationship to find out the enlarged diameter. Now what is that empirical relationship? That D1 is equal to 1.1 times of a D. Okay, that diameter of a rod already you know over here, that you can put over here and you can multiply with 1.1, then you can get the D1. That D1 is nothing but the enlarged diameter, okay, which is connected to the particular diameter of that rod. Okay, now third one, calculate the dimensions A and B by empirical relation. Now again there is empirical relation to find out the dimension A and B. Already in video we have already seen what is A and what is B. Okay, so how to find out? A is equal to again 0.75 times of a D, where B is equal to 1.25 times of a D. Okay, so by using that empirical relationship, you can find out A and B. Okay, for that D you should know, means D means the diameter of rod, and which was already we have calculated in the first formula, right? Now the fourth one, calculate the diameter of the pin by shear consideration and bending consideration, and select the diameter whichever is the maximum. Already we have seen how your pin is going to fail, right? In case of a shear, it is of a double shear case, and bending movement as well, we have seen the formula. Now you have to select whichever is the maximum. If you get the diameter in shear case is maximum as compared to bending, then you can take the diameter which comes under shear consideration. So you have to select whichever is the maximum value. And already there are the formula. Now this formula is based on shear consideration, right? So small d is nothing but the diameter of the pin. Okay, so d is equal to square root of 2p divided by pi into tau. Tau is the shear stress. Okay, and based on the bending consideration, d is equal to cube root of 32 by pi into sigma b into p by 2 into b by 4 plus a by 3. Already we know the value a and b from that third number formula, and then already we know about the tensile force, that is p, and that sigma b, that is bending stress. You can find out that sigma b is equal to bending moment and b into y divided by moment of inertia. So here you can put and you can find out the diameter, okay, under bending consideration. So whichever is the maximum value for that small d, that is the diameter of pin, that you have to set for the further calculation. Okay, because the further calculation you have to choose that small d, that's why you have to choose the maximum one. Okay, is it over up till this? Please, yes. Have you note down these formulas? Yes, please. Yes, please. Once I'm going through each and every one, at that time we have to note down. Yes, please do it fast. We have to see one problem based on it. Yes, so all these are the first four formulas where you can find out the dimensions of each component for the. Now you can find out the diameter of a rod. You can find out the enlarged diameter. You can find out small a, small p, that is width. Then you can find out the small d for the P, that is the diameter of the P based on shear concentration and based on bending concentration. Okay, I am going to share this PPT as well. Just you can go through afterwards as well. Okay. Okay. Now the next, now the fifth one. Okay, I will go ahead now. Okay, now the fifth one is the calculate the dimensions, that is D0 and D1 by empirical relationship. That D0 is the outer diameter of the single eye. Okay, and D1 is the inner diameter of the single eye. So that is D0 and D1. Okay, now again you can find out that D1 and D0 by empirical relationship. Now what is that empirical relationship? Here it is. Okay, that empirical relationship is, okay, I'm sorry, d0 is equal to 2 times of a d and d1 is equal to 1.5 times of a d. Okay, so this is the empirical relationship to find out the d0 and d1, that is outer diameter of the single eye, and d1 is the inner diameter of the single eye. d0 is equal to 2 times of a d and d1 is equal to 1.5 times of a d. Now this outer diameter and inner diameter are based on a diameter of the pin, right? Here, so that's why you need to first find out the diameter of the pin, because it is multiplying factor, that is 2 and 1.5, to find out the d0 and d1. Okay, so I think, is it over up till this? I will go ahead now. Yes, okay. Now the sixth one. Now the next, check the tensile, crushing, and shear stresses in the eye. Already I have told you. Now you have to check the tensile, crushing, and shear stress in the eye, single eye, as well as in the double eye. Okay, but that three conditions is applicable for both, for single eye and double eye. Okay. Now first we'll go for the check the tensile stress. Now that sigma t is equal to P upon B into D0 minus D. Okay, outer diameter minus inner diameter. Now this is for the tensile stress. Now we are checking, okay, for the single eye based on tensile stress. Now next, based on crushing stress. Okay, sigma c is the crushing stress, is equal to P upon B into D. Now already we have seen how it comes in earlier videos. Okay, so don't get it panic how it comes. Okay, so already we have seen it. Okay, so this is about the crushing stress, and then shear stress. Tau is equal to P upon B into D0 minus D. So all these three things are related to the tensile, crushing, and shear stresses in the single eye. Please note down this important formula. Without that, you can't find out the stresses which are in that particular component or in that single eye. Okay. Now the same for check the tensile, crushing, and shear stresses in the four or double eye. Okay. Now just we will go through the formula now. Sigma t in a four. Now if you compare to the eye single eye, and here it is sigma t is equal to p upon 2 into a into d0 minus d. In case of a single eye, it is b into d0 minus d. But here 2 times a into d0 minus d. Okay. So this is for the tensile stress in the four. Now the next is a crushing stress in the core. Okay, now here is P upon 2 times of A into D, but in case of a single eye, it is P upon B into D. Okay, so that is the difference. Okay, now by comparing like this, you can remember the formulas. Okay, so on this six, once you will compare it, okay, what it is in a single eye and what is in a double eye. Okay, so the six formulas you can remember very easily. Now for the shear stress, now tau is equal to PP is the same in a numerator, only change in a denominator, because force is going to act, that is tensile force is going to act in that assembly. So P upon 2 times of A into D0 minus D. So D0 minus D is not going to change, only change in a that outer part, that is here is B in case of a single eye and here is 2A in case of a 4. Okay, so these are the formulas for checking the tensile, crushing, and shear stress in a single eye and in a double eye. Okay, all of you, are you getting this? Okay, up till this, I will note down it. Yes, please. Yes. Okay, so I think all of you get that. Okay, so first is what? You need to find out all these things, that is diameter of the rod, then enlarged diameter, then that A and B value, then small d, that is diameter of the pin, then D0 and D1. Okay, so all these things you need to first find out. Okay, then you can find out the stresses, that sigma t, sigma c, and tau. Okay, but you need to cross check where that sigma t you are getting by using this formula is under permissible shear stress or not. If it is beyond the permissible shear stress, then your single eye is going to fail. It should be less than the permissible tensile stress value. Okay. Then again same for the crushing stress. It should be less than the permissible crushing stress value. It should be less than the shear permissible shear stress value. Then and then your component is the same. Otherwise, if your value is exceeds than permissible stress values, then your single eye is going to fail. Same is applicable in case of a force. Okay, all these value should be in a permissible, should be less than the permissible stress values, right? Then and then it is safe. If it is exceeds the stress values, then what will happen? Your four or your single eye is going to fail. So every time you should consider the stress values, the permissible stress values. Okay, all I think all of you get up till this. So again, are you understand up till this? Okay, so this is the design procedure for the knuckle joint. Okay, now we will see one problem based on this. Okay, which is from the VP Bhandari book. Okay, so now here is the example. Okay, so it is required to design a knuckle joint to connect two circular rods subjected to an axial tensile force of 50 kilonewton. Okay, now the knuckle joint, it is connected to the two circular rods and which is under axial tensile force of 50 kilonewton. Okay, and the rods are coaxial and a small amount of angular movement between their axes is permissible. Okay, so they are coaxial rods and some amount of angular movement permissible in their axis. Okay, at their axis, between their axis. Okay, so design the joint and specify the dimensions of its component and select the suitable material for the parts. Okay, so only that much statement they have given you, but they have given you the axial tensile force value, which is of 50 kilometer. Okay, just 1 minute. Okay, now what is given? Yes, P value is given. Okay, that is axial tensile force, which is of how much? 50 into 10 raised to 3 Newton, right? Now they have also state in a problem that we have to select the suitable material. Now here just see the part one, the selection of the material. Okay, first because we need to first select the material. Without selecting the material, we can't get the yield strength of that particular material. Okay, so here is the assumption. You can select the material. Okay, so the rods are subjected to a tensile force. Okay, therefore, the yield strength is the criteria for the selection of the material of the rods, right? So already they have told you the rods are under tensile force. That's why the yield strength will be the criteria for the selection of the material of the rods. Okay, and that pin is subjected to the shear stress and bending stress. As already we have seen, that pin is under shear stress and the bending stress. Okay, so therefore strength is the also criteria for the material selection for the pin, right? So on the strength basis, the material for the two rods and the pin is selected as a plain carbon steel of a grade 30 C8. So plain carbon steel is selected for that particular knuckle joint. Okay, and which is having yield strength of 400 Newton per mm square. Okay, so it is further assumed that the yield strength in a compression is equal to the yield strength in a tension. Okay, हे पण assumption इथं केलेलं आहे that yield strength in a compression is equal to the yield strength in a tension. Okay, that SYC is equal to SYT. Okay, so in practice, the compressive strength of the steel is much higher than its tensile strength. Okay, that compressive strength of the steel is much higher than the tensile strength. So this is the part one. Now we will go for the part two, that is selection of a factor of safety. Okay, when in problem statement, if all the things are not given, in that case you can assume or you can take the assumptions for that particular problem. No doubt, no any issue. You will get the full marks in that case. Okay, if you assume the material, any type of a material, but that value should be proper. For the plain carbon steel, yield strength is 400. If you select any other material, the yield strength should be proper one. That should be correct, then you will get the full marks. No problem. Okay. Then part two is of a selection of the factor of safety. Okay. So in stress analysis of a knuckle joint, the effect of stress concentration is neglected. Okay. So the stress concentration effect is neglected for the stress analysis. So to account for this, a higher factor of safety of 5 is assumed in the present design. Here is the assumption one again. Okay, so the higher factor of safety is selected or assumed in this present design. Okay, So you can assume any factor of safety. Okay, but for the uh, stay as for the higher factor of safety here is selected in this problem. Okay, up till this I think you got all the things. We have selected the material, we have selected the factor of safety, right? Now the next thing, okay, so now the part 3, the calculation of a permissible stresses. First, we need to find out the permissible stresses value. Okay, on that basis, we will find them. Already I have told you, we need to find out the failure of your core for a single eye in case of a tensile, crushing and shear stress. Okay, you need to check that with whatever the value, tensile stress or crushing stress or shear stress we are getting value, it should be in the range of it should be less than the permissible stresses. So first you need to find out the permissible stresses. Okay, now how to find out? The first one, sigma t. First I will find out the tensile stress. What is the formula? It is of a yield strength divided by factor of safety. Now already we know the yield strength of 400 divided by factor of safety. Already we have took this assumption as a plain carbon steel, and factor of safety we assumed as a 5. That's why 400 by 5 is equal to 80 Newton per mm square. So this is the permissible tensile stress value. Okay. Now the next, at compressive stress, okay, sigma c is equal to yield strength in a compression divided by factor of safety. Now already we have assumed that yield strength in a compression is equal to the yield strength in a tension. Okay, so already that assumptions we have considered in the selection of the material. That's why yield strength in a compression is equal to yield strength in a tension. Okay, so that is SYT upon factor of safety. Now we already know yield strength value 400 divided by factor of safety is a 5. So that's why 80 Newton per mm square, that is compressive strength or the permissible compressive stress value is again 80 Newton per mm square. Now next is the shear stress. Okay, that tau is equal to yield strength in a shear divided by factor of safety, and which is yield strength in a shear is nothing but it is of 0.5 times of a yield strength in a tension, right? Yield strength in a SYT divided by factor of safety. So 0.5 into yield strength is a 400 divided by 5. Here we are getting 40 Newton per mm square, that is shear stress. Okay, so all these three values are the permissible stresses. So tensile stress is 80, permissible is 80. If your tensile stress in case of a core for single eye, if it is greater than 80, then your component is going to fail. In that case, your design is not safe, right? So in that case, what you have to do, you need to change your material, right? Because it will not be sustainable for that whatever the tensile force they have given in a problem state. So, so here as we are considered plain carbon steel, that's why we are getting 80. But if it is in calculation part, if it is not less than 80, then you need to change the material. Okay. Then if it is in that less than permissible value, then your design is safe. You can go through the plain carbon steel material. Okay, up till this, all of you, are you get this? That up to permissible stresses, how comes the permissible stresses? Please, all of you understand this? Yes, please. Yes, sure. Yes, yes, yes. Yes, Akshay, More, Abhinav. Yes, yes. Okay. Yes, all of you, are you understand this? How that permissible stresses comes? Sigma T, sigma C, and tau. Tensile stress, compressive stress, and shear stress. Yes, very fine. Okay. Now we will go ahead. Okay. Now all these 80, 80, 40 are the permissible stress values. Your design should be less than your permissible stress values. Then your design is the same. Okay. Now the next part. Now the part 4. Now we have to calculate the dimensions. Now calculation of a dimensions. Now first, the dimensions of the knuckle joint are calculated by the procedure already we have seen. Okay. So the step one, first we need to find out the diameter of a rod. Now already we have seen the formula, capital D is equal to square root of 4p upon pi into sigma t. So 4p value already given, that is tensile, axial tensile force, which is of 50 into 10 raised to 3 divided by pi into sigma t is how much? 80. So your capital D is equal to 20.28.21 or 30 mm. We will select 30 mm. Okay, so this is the diameter of a rod. Okay. Okay, so we will go forward, we will go ahead. So now step 2, you have to find out the enlarged diameter of that rod, that is D1. Now already empirical relation is available. D1 is equal to 1.1 times of a capital D, right? So 1.1 into 30 is equal to 33 or 35 mm, right? So this is the enlarged diameter. Okay. So are you going to note down it? So can I go ahead? Yes, please. Yes, I will note down it. Or can I go ahead? Yes, please note down very fast. Okay, so this is about the diameter of a rod and enlarged diameter of a rod. That is capital D and capital D. Okay. Okay. Now the next. Okay, I am going to share the PPT. You can go through it. Okay. Just first understand how it is come. Okay. Now the next step three. Here is the step 3. Now we have to find out the dimensions A and B. Already we have seen the empirical relationship to find out A and B, where A is equal to 0.75 times of a D and B is equal to 1.25 times of a D. Just you have to put the D value, you will get the A and B dimensions. Okay, so A is equal to 25 mm and B is equal to 40 mm. Okay, so empirical based, so this is based on the empirical relationship. Okay, now the next step 4, we need to find out the diameter of a pin. Already we have discussed you need to find out diameter of the pin based on the shear consideration and based on the bending consideration, and whichever is the maximum value you have to say. Okay, now this formula is based on the shear consideration. Okay, so small d is equal to square root of 2p upon pi into tau. Okay, the tau value already we have found out, which is of 40. P value you already know, so just to put the values in a formula and get the answers. Okay. So small d is equal to 28.21 or 30 mm. Okay. So this is for small d. And now based on the bending consideration, the formula is already we have seen the cube root of a 32 of pi into sigma b into p by 2 into b by 4 plus a by 3. Okay, so just we put all here values. Okay, now bending stress is here considered as a not compressive stress. Okay, so here directly we will take it as a 80. Okay, then we will put AB here. Already we have found out 25 40. Here we will put all those values, and just if you do the calculation, then you will get the small d, which is of 40 mm. Now which one is the maximum? Now under shear consideration, d is equal to 30 mm, and under bending consideration, d is equal to 40 mm. So which value I can consider for the further calculation? Yes, please. Yes, right, that is 40 mm. I will consider 40 mm because under bending consideration, I am getting d is equal to 40 maximum as compared to this shear consideration. So I will consider here maximum value d is equal to 40 mm for the further calculation. Okay. Now the next. Okay, now step 5, the dimensions D0 and D, that is outer diameter of the single eye and the inner diameter of the single eye. Now again there is the empirical relationship to find out D0 and D1, where D0 is equal to 2 times of a D, where D1 is equal to 1.5 times of a D. Now 2 into 40. Why? Because here I have considered the maximum diameter value. So 2 into 40 and 1.5 times of 40. So here I will get 80 mm and 60 mm. So outer diameter is 80 and inner diameter of the 60 for the single eye. Now the next step 6. Now I will check for the stresses. Okay. Now I will check for the stresses in eye. What are the check for the stresses? Tensile stress, compressive stress, and shear stress. Okay. Now as per the formula, I will first check for the tensile stress. Now sigma T is equal to P upon B into D0 minus D. Now D0 and D already we have find out, and the B value already we know. So once I will put that all values in that formula, here I will get sigma T is equal to 31.25 Newton per mm square. Can you please tell me whether it is whether it is less than permissible tensile stress or it is greater than permissible shear stress? Yes, can you please tell me that sigma T value, that tensile stress value here we are getting, that is 31.25. Okay, what is our permissible tensile stress value? Can you please tell me? Yes, exactly. Kedar Akshay, yes, it was permissible tensile stress value was 80. So whether it is less than, yes, that sigma T is less than 80 Newton per mm square. So we can say our design up till this is the same. Now I will check for now crushing stress sigma C, right? So what is the formula? P upon B into D. I will put all the values here. Again, I am getting 31.25. So again, it is less than 80 mm. What is this? That crushing compressive stress value permissible 80. So again, your sigma C value here, crushing stress value is again less than 80 Newton per mm square. So up till this, again, it is very safe. Okay. Now the next is what I need to find out shear stress in a single eye. What is the formula? P upon B into D0 minus D. So I will put again all the values. D0 already we have find out that D is the 40. So I will put all the values in the formula. Again, I am getting 31.25. So again, it is less than. Now the compressive stress value of, no, sorry, shear stress value permissible ability 40 Newton. So here is 31.25. So again, it is less than permissible stress value. So all these stresses values are less than the permissible stress values. So up till this design is a set. Means whatever the material you have selected is a safe for the design purpose. Right? Now the next is what? The check for stresses in a what? 4. This is for the single eye. Now I will check for the stresses in a double eye as well. Whether it is lying or less than the permissible stress value, I am going to check. Now the next part is the check for the stresses in a double eye or a 4. Now again sigma t value, then the formula is P upon 2 times A into D0 minus D. I will put all the values and here again 25 Newton m square. Whether it is greater than or less than permissible value, yes please. Yes, so it is less than permissible stress value. Yes, what is less than 80 Newton per mm square? Right. Vijay Shoaib Alfia, yes, it is correct. So here is again you are getting stress value is less than permissible tensile stress value. So again up till this it is correct. Now I will go for the crushing stress. Now the formula is P upon 2 times A into D. So P upon 2 times A into D, I will put all the values and I will get the answer again 25 Newton mm square. So again, it is less than compressive stress value. So that is crushing stress value. Sigma C is less than 80 Newton per mm square. So again, up till this, it is very set. Now, final is the shear stress. Okay, that P upon 2 times A D0 minus D. I will do the calculation. I will put the values. That 2 times 25 into 80 minus 4 and the P value is already known. So again, it is 25 Newton mm square. So again, it is less than that shear stress value is again less than 40 Newton per mm square. So, okay, so up till this, you can say all the stress values you are getting, all the check for the stresses in a single eye as well as in the fourth, they are less than the permissible stress values. So it is observed that the stresses are within limits, right? Because they are very less than the permissible stress values. So here you can say it is observed that all the stresses values are within limits. Okay. So and the final portion, that is part 5, is the dimensional sketch of a knuckle joint. So finally, we need to draw the cross-sectional view of the knuckle joint, and you have to show all the dimensions on that particular diagram. Okay, so this type of problem may be asked for 6 to 8 marks. Okay, you need to remember the formulas only. Just you have to put the values in the formulas and getting the answer. That's it only, and which will give you the full marks. Okay, so this is about the knuckle joint. Okay, now here is the example for the this is your example for today's homework. Okay, so I have also given you the answer for it also. You can cross check the answer as well. Okay, so here is the example for the today's homework problem. Everyone should note down it and everyone should submit it to me on a Google Classroom. Okay, so all of you, I think you got up till this about knuckle joint. Okay, so what is knuckle joint? And today we have seen about the problem based on a knuckle joint. Okay, so this type of a problem is surely going to ask in an in-sem exam or in-sem exam of our university exam. It may be for 6 marks or it may be for 8 marks. Okay, so up till this we have seen about the quarter joint, knuckle joint. Okay, now in the next lecture we are going to see about levers. Okay, the final part of that unit, that is levers. What is levers? What are the types of levers? And the problem based on the levers. Okay, so I will share you this problem on a Google Classroom. Just you can solve this problem. Just you can cross check the answers, and just you can put it on a Google Classroom as a submission. So only one problem. Okay, so